Now we're going to learn something called dimension analysis. Dimension analysis is just a fancy way to say convert. We're going to learn a way to convert from one unit to another using a process called dimension analysis. Okay, so if I told you how tall I was, I would say that I'm 61 inches tall. Well, a lot of times that doesn't make a lot of sense to us. We kind of, in the United States, we talk about how tall you are in feet, maybe feet and inches, but not just inches. So I'm going to teach you how to convert using dimension analysis. Now everyone knows that if I'm 61 inches, I'm 5 foot and 1 inch. Still short, but that's okay. But I want you to be able to use it doing dimension analysis, because the dimension analysis is so useful, and we'll use it when we do stoichiometry. That many of you are going to go into some sort of medical profession maybe, and so if you were needing to convert from like milligrams to micrograms, this would be a very good way to do it. Dimension analysis is used in physics. It's used in all sciences really. So I'm going to do it using what I call the tic-tac method, dimension analysis table. Some of you've used parentheses, so I'm going to show you both ways, but then I'm just going to start using the dimension analysis table and not the parentheses, but you're welcome to use either way. So in my first problem, I've got 61 inches and I'm trying to convert it to feet. Now everybody does know that I'm just going to be dividing by 12, so that's not the point. The point is not just, oh, you divide by 12 and then you get your answer. Is how do you get to that point? And that's what I care more about, is how do you get to that point. So you start with the number and the unit that you are trying to convert. And so I would take 61.0, which is 3 significant digits, by the way. And I would put the unit, which is inches. And then you're going to make it a fraction, and the way we make it a fraction is just by putting it over 1. Putting a number over 1 doesn't change that number, so that's still 61 inches. Okay, so this is going to help me set it into a table. As I do the table, then I'm going to draw this bar here and a bar this way. And so what the bar this way means is divide, like it always does in math. It means a division, so this means division. What this line here means is multiplication. So when you see this, this means multiply. When you see this, this means divide. So that's why we're going to start setting it up. And then you're going to take the unit, not the number, but the unit. So this unit, inch, and we're going to move it diagonally in this corner. So I'm going to take inch and move it diagonally in that corner. So I'm going to go back to the blue. So the inch is going to move here. What that's going to do is allow me to have a way to cancel units out, because in math, if you have a number on the top or a unit on the top, such as x, and an x on the bottom, they would cancel each other out. So the fact that inches is on top and the inches is on bottom, they're going to cancel out. If I know the conversion from inches to the unit that I'm looking for, in this case being feet, then I can, go directly to feet. And then we have a simple table, what I call a two-step or a tic-tac table, dimension analysis table. And then so we're going to set this as an equal statement, and we want to know, well, how many feet equals how many inches equal how many feet, basically. And we do know that in 1 foot there are 12 inches. So when I said 1, it was with the word foot or feet, and so the 1 is going to go with feet, because 1 foot, that is the larger unit. 1 foot equals 12 inches. So 1 foot equals 12 inches. This is called a conversion factor, and I should be able to read that out loud and make it as an equal statement. Okay, many times students will do this. This is what I'm about to do is wrong. They'll put the 1 here and they'll go 12. If I read this out loud, that says 1 inch equals 12 feet. That is not a true statement. 1 inch does not equal 12 feet. So you should be able to read that conversion table out loud and it be a true statement. So in 1 foot there are 12 inches. These two things here we're going to cancel because one's on top and one's on bottom. And then the unit you're looking for should always end in this top right corner. Alright, so now you multiply across the top, so 61 times 1 is 61, and the feet stay because it didn't cancel. 1 times 12, because remember this line means divide, I'm sorry, this line means multiply. 1 times 12 is 12. And I would simply take 61 divided by 12, which is what many of you wanted to do in the beginning. But this is a process, so when we start doing like atoms and molecules and formula units and grams and things, if you learn this process, it'll be very easy and it'll make sense. So I'll take now 61 divided by 12 in my calculator, and the calculator will spit out 5.08 and then a bunch of repeating threes. Well, in the beginning I said we had 3 significant digits, so we want to base our significant digits or significant figures on the amount of the number that we are converting, not the conversion factor that we're using, but the beginning number that we started with. And there was 3. I usually like 3. So this would be, there's my 3. That is not a 5, so I don't need to round up, so we would simply put 5.08. All right. So now we begin with this one. We've got 70.0 kilograms. I have 3 significant figures again. And I'll put it over 1. We're going to make the little table. And I'm going to bring kilograms down. And I'm going to bring pounds to the top because this is actually a conversion factor that you should start to learn if you don't know it, because you'll use it a lot, especially if you want to go into something in the medical profession. But even if you didn't know it, I'm going to go to page 2 here, and here's some common factors. You don't have to memorize these. These are just some common metric to English factors. And so you see right here is the one that we're dealing with. 2.2 pounds equals 1 kilogram. So the 1 is with kilogram, the 2.2 is with pounds. 2.2 is pound. Kilogram is a larger unit, so we can go direct because I do have that conversion. And in 1 kilogram there are 2.2 pounds. So in this time, can you see the kilograms are going to cancel out, and I'm going to multiply across the top, and I'm going to get 154. I didn't write the stuff that went behind it because there's 3 sig digs. There's 3 sig digs. The unit is pounds. If I do the bottom, can you see the bottom is just going to be 1? So you get 154 divided by 1. You get 154. I did mean to say up here at the top, some of you may not have used the table before, and you may be used to something like this. I'm going to use this one for an example. It's very similar, and I think Chem 101 actually uses it. They use parentheses. So they'll put parentheses and another set of parentheses, bringing kilograms down, pounds to the top, and in 1 kilogram there's 2.2 pounds. You can see those are going to cancel. So this is the same scenario using parentheses. So you're welcome to use parentheses, or you can use the table, whichever you prefer. Okay, Chem 101 will put those parentheses there for you. So this here is really the same thing, the exact same thing. I'm just lazy, and I got used to using the table a long time ago, so I still use the table. All right, so let's move on. So the next one I want to point out, we've been going some sort of English system. That's still English system. This is a metric system to the English system. But now if we'll notice, this one is a metric system to a metric system. So some sort of metric to metric. And we do that a lot. We stay within the metric system. The metric system is a big part of the international system, which is known as the SI system that we use in science. Okay, so the international system does include the metric, and it has some other things as well. All right, so we're going to begin. Over 1, we draw a little line. This is known as a base unit. A base unit in the metric system are grams, meters, liters. Those are things that you should have learned in high school. Your basic grams measure some sort of mass, liters measure some sort of volume, and meters measure some sort of distance. So those are your base units. You have other ones, like seconds is actually a base unit. Now that we get into computers, bytes is actually a base unit in the metric. So this is a base unit. So if it's a base unit can go directly to the unit that we're looking for. Now let me go to that page there was those common metric conversions with English to metric, but here is the metric system. This is not the complete metric system, and I used to put meters on the end of this and it confused students, so I just put the base. So this is some sort of base. So this could be 1 teragram equals 1 times 10 to the 12th grams. This could be 1 terameter equaling 1 times 10 to the 12th meters. So your bases can be either meters, grams, liters, bytes, seconds. So I would replace the word base with one of those. What you have to make sure you do is you don't get a meter equaling a gram, because a meter is a distance measurement and a gram is a mass measurement. So these are just your prefixes. I used to make students memorize these, but because of the online factor, I'll let you use this. Okay. So we had kilo. So it says 1 kilo, and we were dealing with kilograms is what we're looking at. 1 kilogram equals 1,000 grams. So 1 kilogram equals 1,000 grams. When it says base, kilo base, you're replacing that with the base. Hopefully you can read that, make that make sense. And you got an or here because I like to deal with the positive exponents, and if you use the positive exponents, you always put those values with the smaller unit. So this is the ones over here that I use, because I'd always put one with a larger unit. Notice these have ones with them. But some of you may have learned it negative. If you learned it negative, you'll be using this side. So either one, you'll use this over here or this over here. They're really technically the same thing. I'll show you in a moment. Well, might as well show you now. Let's go with this one, because this one's most students understand. Let's talk centimeters. If you had a ruler, there are actually 100 centimeters in 1 meter stick. So if I counted the little lines, not the little lines, but the bigger lines on a meter stick, there are 100 of them. Centi meaning 100, like cents. There's 100 cents in a dollar. Okay, so centi means 100. So this is a true statement. That's what this one's saying. Or another way you could say it is if you had one tiny little centimeter, it would be this much. Whoops, I put one too many zeros in there. Do apologize. That many of a meter. So that's a true statement. That's what this one's saying here. So this is true statement, that's a true statement. So you could use either one. I'm not a big fan of the decimals. I kind of like that one up there. Whichever you prefer though. Alright, let's work that one up, that problem we just had. So, which was bigger? Well, a kilogram is bigger. So in 1 kilogram, there are 1,000 grams. In 1 kilogram, there are 1,000 grams. Got my unit that I was looking for. So I'm going to multiply across the top and multiply across the bottom. Top divided by bottom, I get 1.86. All right. Now, that may not be the easiest way to convert in the metric system. Some of you may have learned up and down the stair steps and things like that. I'm just using that to show you it can be used dimension analysis wise. Alright, so if we look at the next one, we have 3 feet trying to go to centimeters. So we got feet and we're trying to get to centimeters. Feet and we're trying to get to centimeters. I'll come back down here. So let me go to the next page here where we have those conversions. And just let's see, do we have feet and centimeters? There's centimeters, but it's not to feet, it's to inches. So what I'm going to have to do is I'm going to have to go from the feet, let me go back to my page, 2.54. I'm going to have to go from the feet to the inch and then to the centimeter. So from feet, I'm going to have to go to inch, and then from inch to centimeter. And I want you to just try to figure it out. I want it actually to be a 3-step problem there. Okay? So let's begin. I've got a weird thing going on here, so let's go down here. So we have 3 feet. And feet's here. Now I could Google, but I'm not wanting to Google, so I'm going to go to inches. So So in 1 foot there are 12 inches. True statement, right? 1 foot there's. So if I stop right there, I'm going to have inches, and at that point I could do a second conversion, or I could just keep this one rolling, which is what I'm going to do. So I don't want inches, so I'm going to bring inches down. Inches is going to end up right there. And so from inches, I can now go to centimeters. And then if we go back to that thing, it said that in 1 inch, there are 2.54 centimeters. In 1 inch, 2.54 centimeters. These will cancel. And can you see that I got this in that top corner, exactly where I want it to be? Alright, so I'm going to multiply. The bottom's easy. It's going to be 1. I'm going to multiply across the top, and I'm going to get 91.4444 repeating. So for sig digs, there are 3. So I can do 90, I'm sorry, I said 94, 91.44. Okay, 91.44. 91.4 for 3 sig digs, which is what I want because that's what this number has here. Alright, let's look at a couple more. So now we're going to go metric. So we're going to pretty much stay in the metric system here with those. And can you see here that I've got gigameters and I'm trying to get to millimeters. So I've got one prefix trying to go to another prefix. And I don't want you to figure it out in your head. And some people can, some people can't. They do a bad job when they try. So what you're going to do is always a 3-step problem. If you've got something with a prefix, metric, going to something else with a prefix, metric, it's going to be a 3-step problem. And you're going to have what I call a go-between. Your go-between is the base unit. So in this case, I'm going to go gigameter to meter. And for meter, I'm going to go to millimeter. Okay, can you see that? This is the base unit. Later, our base unit is going to be the mole. So it's going to kind of get important to start getting used to going to the base unit. Okay, so I'm going from gigameter to the base unit. It's almost like those two things with prefixes that don't talk to one another. I don't know if you've ever been mad at someone and you're like, I don't want to talk to that person, so you'll tell someone else, hey, go tell that person to tell that person. Well, that's what the base unit is. It's that go-between because the other two units are not really cooperating with one another. Alright, so let's begin. So 20.0 gigameters over 1. And what I'm going to do in the beginning is I'm just going to set my bracket, and then I'm going to go back and put numbers. So I'm going to always tell you, set your bracket. Okay, so then gigameters is going to come down, and the go-between guy is going to the top, which is meters. Those are going to cancel. Alright, I'm not going to put numbers yet. So is meters what I'm looking for? No, I'm looking for millimeters. So I'm going to bring meters down. That catacorner thing, it's for, so I'm bringing it crossways to make it cancel out. And from meters, because meters is a base unit, the base unit can go directly to millimeters. Okay, now do you see meters are going to cancel, and I'm going to be left with millimeters, which is what I'm wanting. I'm wanting this to end right there in that corner, which is exactly what I've got. Now I would go to that conversion page and look back at the numbers. If I go back, and I've uploaded that so you can print that sheet out, or you can just have it up on your computer, whichever. I will give it to you on your test, so it'll be okay. So basically in metric you say which one's larger. Giga is larger, and in 1 gigameter there's 1 times 10 to the 9th meters. Which one's larger here? Between a millimeter and a meter is larger, and there are 1,000 of those. So again, bottom's hard here is going to be 1, and I would multiply across the top, and I would get 2 times 10 to the 13th power millimeters. Now, this has 3 significant figures. That right now only has 1. So to make it have 3, I'm going to add 2 more zeros. And there's my answer. Alright, so look at this one. Prefix, prefix, metric, metric. So I'm going to go from terabytes to bytes, and from bytes I'm going to go to megabytes. Careful with the M's. Big M is mega, little m is milli, and then there's this weird symbol called mu, which is micro. Let me show you micro real quick. Okay, look here. There's big M, that's mega. Little m is milli. Micro is called a mu. This is the Greek symbol for micro. I will tell you, in physics and chemistry we still use micro. It's called mu. It almost looks like a backwards U or something like that. But I've talked to several of my friends who are nurses, and they say in medicine that they've gone away from using mu because that would be a microgram. That's how it would look. And when doctors and pharmacists and people read and write real fast, that could get misinterpreted for a milligram. And if you needed to give someone a microgram of something and you gave them a milligram, that person could be dead. So that's not a good thing. So in especially medicine, they're using mcg for microgram. So that's why I put mc there. So mcg is microgram. That's also microgram. If you're going on to physics and stuff, you might as well get used to seeing that little mu micro symbol there. So just wanted you to be familiar with that. All right, on we go. So we're going to go 60. Oh, there he is down there. Okay, 60 terabytes. We're going to go over 1. Because it's got that in between, it's actually going to be what I call a 3-stepper. So what's going to go in this corner? Well, this unit goes down. Notice that number never moves, so that unit goes down. And I'm going to go, I did not finish out that B over there. I'm going to go to bytes. So terabytes to bytes. I don't want bytes, I'm trying to get to megabytes. So then coming down cat a corner will be the bytes, and then I will go to megabytes. See how this is nice and canceling, and that's nice and canceling. I've set my bracket, I got what I want in that top corner. So now I'm going to put my conversion factors in there. So between these two, whoa, I put megagram. Someone here. It's the bad thing about not being face to face. No one's here to check me. So I may make errors, so please forgive me if I do, because I am human and can do that. Alright, so in one of those there is actually 1 times 10 to the 12 bytes. Terabytes, you can buy terabytes of memory now. Okay, what's bigger between those two? Well, mega is bigger between those two, and so in 1 megabyte there is 1 times 10 to the 6. So I would multiply across the top, and you're going to get 6 times 10 to the 13 megabytes. And then on bottom, you'll get 1 times 10 to the 6. And no unit with that. And then we will divide those. Remember, if you're going to divide, you can subtract those. Make sure you can do it in your calculator to check yourself. We need 3 sig, so 6.00 times 10 to the 7th power there. Alright. I just have 3 of those just to keep you going here. Alright, so microgram to kilogram. So who do they have in common? The base unit that they're sharing with one another. So I'm going to use mcg. Microgram, we're going to go to gram, and then from gram we're going to go to kilogram. That's our little pathway we're going to go. So 28, whoa, that's pretty ugly, 28 micrograms over 1. It's going to be a 3-step, so go ahead and do that. Microgram is going to come down. Where am I going to go? From microgram, I'm going to go to the base unit, gram. Okay. Do I want gram? No. So gram's going to come down, and from gram I can go to kilograms. Okay, these are going to cancel. Those are going to cancel. Ready to put some numbers in. Going from the chart there. And so which one's bigger, a gram or a microgram? Grams are bigger, so in 1 gram there's 1 times 10 to the 6 micrograms. Which one's bigger here? Kilo's bigger, so 1 times 10, 1,000. 1 times 10 to the 3rd is where I was going with it. I get used to using scientific. There you go. 1,000, or 1 times 10 to the 3rd. If you use scientific, you can actually see the numbers a little bit better. So you're going to end up with 28 kilograms on top, and 1 times 10 to the 9th on bottom. Divide those out, you get 2.80 for sig digs times 10 to the negative 8th power. All right, hopefully that's making sense to you. All right, next one. Do you see this? This is what's causing problems on this one. I'm going to teach just what I think is the safer way to do this one. Students make less errors doing it this way. There's another way to do it. This is the safer way to do this one. This one is a square. You would have done maybe an area, length times width. And so this unit somehow has maybe a centimeter by a centimeter. Somehow we got 256 centimeters. So we're going to begin this one very similar. Over 1. But here's the problem. I'm not just going to put centimeters squared down here. I've got 2 of these to cancel out. Kind of like in algebra, if you had x squared on top, in order to cancel them out, you technically need 2 x's on bottom. Well, because I need 2 of them, I'm going to do 2 brackets. See if this makes sense to you. I'm going to put a centimeter here and a centimeter here. Because I need 2 of them, so I'm going to put 1 here and 1 there. That's going to give me 2 of them, because centimeter times centimeter is centimeter squared. This is the safer way to do it. I promise it is. There's another way to do it that's maybe easier, but students will forget to square things and then they get wrong answers. This is safer. All right. If this had been 3 centimeters cubed, I would have drawn a 3rd one. Okay. 4th, I would have drawn a 4th one. So centimeter to centimeter, that's going to cancel those 2 out. And I need 2 meters. I'm going to put 1 here and 1 here. I shouldn't say 2 meters, but meters squared, because this is going to be a meter times a meter, which is going to give me a meter squared. Can you see that? That there's 2 of those, 1 of them, 2 of them going to cancel, and when I multiply a meter times a meter, I'm going to get a meter squared. So that's how I would work that. Now we go to our conversion. This one's bigger. 1 of those equals 100 of those. 1 of those equals 100 of those. Going to multiply across the top. Don't square it. No squaring. It's already been squared, so just 256. Meter squared, because it's a meter times meter. And then it's 100 times 100. A lot of times students will add those. 100 times 100. And so you're going to get 4 zeros. What's that? 10,000? And then we're going to divide. And if we divide these out, we get 0.0256, or you could put it in scientific notation of 2.56 times 10 to the negative 2nd power. Either one's fine. All right, so that's if we have what we call not a linear, so we either have a 2-dimension or a 3-dimension. You would have to convert your units that way. All right, last one for this video. This one would be what we call a double converting. You see it in physics quite often. We are trying to get meters to become kilometers and seconds to become hours. So it's a double converting going on here. So the way you do this is very similar. I'm going to go ahead and do my start bracket. My number here, so my 45.0, but I can only put 1 unit up here, not 2 units, because that's got 2 units. I can only put 1, and this little line here means divide anyway. This is meters divided by seconds. So if it's divide by, seconds needs to be on bottom. So I'm going to put the meters here and the seconds there. Does that make sense? Meters there on top, seconds on bottom. Well, seconds is looking a little bit lonely, so we're going to put that 1 with it. So for every 45 meters, we're going 45 meters in 1 second. This would be a speed. So that's why I said you could do it in physics like that. All right, so we're going to ignore the seconds for a second. We're going to ignore that. We're not going to pretend he's not even there. We don't need to mess with him right now. We're going to just try to get the meter to become kilometers. So ignoring this guy, we're going to take this meter and move him crossways. And from meter, we're going to put kilometer. Okay, can you see these canceling? When I taught this in high school students, I would tell students when they get to the unit that they're wanting on top, put a box around it. You don't have to, but put a box around it. If it gets boxed, that means don't move it, because I don't want to move that guy, because if I get ready to move him, then he's going to disappear, and that's one of the ones I'm wanting. So I'm going to leave him there. Now I'm going to put some numbers in there. For every 1 kilometer, there are 1,000 meters. That's a true statement. Okay. But I'm not done, because that's just giving me, if I stop right now, I'm going to have kilometers per second. I don't want kilometers per second. I want kilometers per hour. So now this is where it gets weird. Okay, remember the seconds that we were ignoring a second ago? So this seconds is on bottom. To make him cancel, I need to bring him to the top. So I'm going to take this seconds, not the 1, not that it matters, but no, don't bring the 1. It does matter. I'm going to take this seconds, I'm going to take it to the top, because I'm basically taking it opposite from the location that it's at. It's on bottom, I'm taking it to the top for cancellation purposes. Okay, so I'm going to move that. Get back to my blue. So I'm going to take it seconds there, and from seconds I'm trying to get to hours. This is not one of the ones I gave to you, but I kind of would like you to know in 1 hour, if you want to write this on your sheet, maybe I'll put it on there before I upload it. 1 hour, there's 3,600 seconds. If you don't know how I got that, 60 minutes and 60 seconds, 60 times 60 is 3,600. So in 1 hour, there's 3,600 seconds. So in 1 hour, there are 3,600 seconds. Okay, and I actually just got the final answer. I did not do the individual. So let me grab my calculator here quickly. So 45, of course, times 1 we don't need to do, but times 3,600, we get 162 and then 3 zeros. And do you see, the seconds canceled out. Look what's on bottom there. So you can see the units on top is the kilometer. And I'm going to go 1 times 1,000 times 1, so 1,000. And then we still have hours hanging on bottom this time. Before we didn't have anything on bottom. So now I would do 162,000 divided by 1,000, you would get 162. So 162 kilometers per hour. This is called a double conversion. And that is basically all our different types of conversions. There's several really good examples on Chem 101. So please email me. We can meet on Teams if you have any questions over this.